So let us look at some problems on combinations now. So that will help you to get a better understanding. So the first problem is that 7 points lie on a circle. How many chords can be drawn by joining these points pairwise? So in case you don't know what is a chord, I hope that you know, but I'll just refresh your memory. If you have a circle and I have 2 points, 1 and 2, so I'll call these points A and B. Then a chord is the line joining these 2 points on the circle. So if I had one more point, C, then there will be a chord between A and C and B similarly. So like that. So in this problem you have 7 points. So you have only 3 points here. So you get that idea. So the point is that how many chords can be drawn by joining these points pairwise. So if you had 3 points, then you can only have 3 chords, right? Because these are the only chords possible. So now you have to solve the problem for 7 points on the circle. So the choices are 46, 42, 21, and 8. Okay, the correct answer is 21. So let us look at the solution. The solution is actually pretty straightforward once you know that it's an application of the combination formula directly. So like I told you before, that if you have a chord, like if I had 2 points in the circle A and B, so every 2 points have a chord between them, right? Does it matter if we have a chord between B and A to B? Not really, right? So the chord, for the chord, order does not matter, right? AB is same as BA, right? So you just have a line between A to B and there's no direction. So in this case, we can apply combinations, right? Because we have to calculate the combinations or the selection. So what you have to do is, if we have 7 points, we have to find the ways to select 2 points. That is the same as what the question says, pairwise selection, right? Pair is 2, so just we have to find the ways to select 2 points. In how many ways can we select 2 points out of 7? That's straightforward. We have 7 different points and we have to select 2 points, and that is 7 choose 2, right? Because this is 7, I will again write it down, 7 different points taken 2 at a time, where points cannot be repeated. What does it mean that points cannot be repeated? That means that you can't have the same point. If there's a point A, you can't use the same point to again. So there won't be a chord between a point and itself, right? So these kind of chords are not allowed. Only points like A, B, and if C is another point here, then there can be a point. There can be a chord between there, right? So A, C, A, B, these are the points we are looking at. So 7 choose 2 is the answer, and 7 choose 2 is 7 factorial divided by 2 factorial divided by 5 factorial. So it's the application of just the formula which we had. I will write down the formula also again in case you don't remember, but you should eventually, and that's what I have applied here. So pretty straightforward. It is 7 into 6 divided by 2 that is 21. So please get better and better at using the factorial notation and cancelling off the numerator and denominator. Here I just cancelled out 5 factorial with 7 factorial and was left with 7 into 6, and 2 factorial was 2, and that's how I got the answer. Okay, so let us look at another problem now. So here is the problem. A committee of 3 people is to be constituted or made from a group of 2 men and 3 women. The first part is, in how many ways can this be done? And the second part is, how many of these committees consist of 1 man and 2 women? So let me just give you the choices. The choices are 10 and 8, 8 and 6, 10 and 10, and 10 and 6. So the correct answer is 10 and 6. So let us look at the solution for the first part first. First part should have been very straightforward. So we have 2 men and 3 women, right? So let me call them, say, M1, M2. The men are M1, M2, and women are W1, W2, and W3. So first question we want to ask is, if we are selecting these 3 people, we have to select 3 people. Whenever there is a selection of 3 people, like M1, M2, and W1, does it matter if we change the order? If we change the order to M2 first, M1, and W1, does the committee change? No, right? So the committee remains the same and the order does not matter if these 2 are the same committee, right? So therefore this is very important, that the order does not matter. Once we know that order does not matter, we should think towards combination. When order matters, then it is permutations or arrangements. You have to take all the arrangements. These arrangements are different. So now we have to, out of these 5, we have to select 3, right, for the committee. So how do you select 3 objects out of 5? Just straightforward 5C3, right? This is how you do it. You have to select out of 5 different objects, 3 objects, and I will emphasize again that we cannot repeat the same object again. So we cannot have a committee like M1, M1, and M2, right? That's why this formula applies, because this is a selection of 5 objects taken 5 different objects taken 3 at a time, where repetition of the objects is not allowed. So this is right. And then you just apply the formula, 5 factorial divided by 3 factorial and 2 factorial, and this will give you 5 into 4 by 2 or 10. So this should be fine. So again, I am just cancelling 5 factorial with 3 factorial, and you will have 5 into 4 left, because 5 factorial is 5 into 4 into 3 factorial. So this is the solution for the first part. Let us look at the second part now. The second part is much more interesting actually. So in the second part we have to select 1 man and 2 women, right? So in this case, if I label the men as before as M1 and M2, and women are W1, W2, and W3, what I have to do is select only 1 from these 2 and 2 from these 3 women. So I want to form a committee like, say, M1, I am picking 1 from these 2, and W1 and W2 from these 3 women, Similarly, I can pick M2 and W2 and W3 and M1 and W1 and W3 and so on. So I have to find all the committees which are possible, taking one from here and two from the women's group, right? So it's different from the previous question, because in the previous question I considered all the 5 as one group, and in this case I have to select one from the first group and two from the second group. So these kind of questions will appear again and again, so which will involve using fundamental principles of counting. How? Because this is the event of selecting one man from two men and selecting two women from three, right? So this is what is important in fundamental principles of counting, and right, you want these two things to happen simultaneously. We have to select this and this. So that means we just have to, how many ways can you select one man out of two men? 2C1, or 2 choose 1, right? And you have to multiply this event, as we are using fundamental principles of counting, 2C1 into choosing two women out of three, that is 3 choose 2, right? And now we can get the answer, which is 2 factorial divided by 1 factorial and 1 factorial. I'm just replacing the formula for 2C1, and for 3C2 we just have 3 factorial, 2 factorial and 1 factorial. And if you solve for this, just go a little bit down in the page. So it will be 2 into 3, that is equal to 6, right? So we got the answer. So here it's just from fundamental, I'll just write it down so that you remember. You have to use fundamental principles of counting so many times that you should be able to know that this, you have to multiply these two selections together. But just for the sake of completeness, I am writing this down. Okay.